Hello, Olathe West ACT preppers. What we're going to do today in the mathematics section is we will be going over the ACT practice test that everyone took a week or two ago. Things you will need. Well, graphing calculator for sure. Your practice ACT results. Now, if you took the practice ACT test, your seminar teacher will have passed back your results from the test. That was probably done maybe last week. Hopefully you still have those. It would be great to be able to go through those and look at the questions that you missed. We're going to look at questions that most students miss, so you can see, but be really particularly important to look at the ones that you missed. As always, something to write on, and it's a pencil or pen, right? Good attitude, willingness to learn. So let's go ahead and get started here. On the very first question of this test, only 53% of people got it right. So what I'm doing on this is on the left-hand side, I am putting down the percent that students answered. So 7% answered choice A, 23% chose choice B, and so on. I'm highlighting the correct answer, when this case is E, 53%. So this is a probability question. And the question's asking us, what is the probability of drawing a piece of paper with a number less than 9? Now we're told that the numbers 1 through 15 were used. So the numbers that are less than 9 are like, 1, 2, 3, 4, 5, 6, 7, 8. We're not going to include the number 9, right? Those are the ones. Now for probability is always favorable over total. There are a total of 15 numbers to choose from, right? Out of these 15, there will be 1, 2, 3, 4, 5, 6, 7, 8 of them that we're looking for. So we are looking for 8 out of 15. Now, a lot of 23% of people chose letter A, they chose letter B, 1 out of 15. I think we can all agree there's more than one number being chosen here, right? Less than a 9 written on it. These are all the ones less than 9. Okay, let's go on to the next one. It's question number 2. And on, sorry, hold on a second here. Okay, there we go. Sorry, a little technical issues there. This is question number 2. Again, a little better than the first one. We're trying to combine terms here. Now, we need to remember that you can only add things together that are the same exponent, right? So if I look at this, we have negative 4x to the third. We also have a negative 12x to the third. And then we have a positive 9x squared. We can add together things that have the same exponent. Those would add up to be negative 16x to the third. And so that's why it would be letter J. Now, the people that chose letter K, I'm thinking they added the 2 exponents. They did 3 plus 3 and got 9. Remember, when we're adding things, we do not want to add the exponents. The exponents stay the same. I'd imagine the people that got letter F were just marking whatever on their test. So, and then the G, not sure about that one either. I think those people just kind of added everything together. All right, let's look at the next one here. Question number 3. Again, just over half of us got it right. And they're saying when X is equal to 2, how much is all this? Well, there's 2 ways to do this problem. One way is to, plug in a 2 in for the X, right? So here's our 2 that we're plugging in for the X. And we know that we should be working from the innermost parenthesis first, right? 3 times 2 is 6. 12 divided by 6 is 2. We're going to multiply next and get 16 for an answer. But the thing is, you can use your calculator on this entire test. Once you've done plugging the numbers in, why not just type it all into your calculator? Right? 16. Should try to do that. That would be the best way to go about it. Let's take a look at the next one here. This one's a similar one. Half of us got it right. And I'm thinking some people chose letter J because they were thinking absolute values always give positive answers. Yes, but there's something interesting going on in here with the subtraction sign. So what we should do is go ahead and figure this out. 6 minus 4. Well, that's going to be a 2. And then 3 minus 8. That's going to be a -5. So our problem comes down to this. Now, the absolute value of 2 is 2. Bring down our subtraction sign. The absolute value of -5 is 5. 2 minus 5 is -3, which would be the correct answer. I'm thinking people chose J. They thought those two minuses kind of canceled each other out. Now, again, you can use your calculator on this. There's an absolute value choice. If you press alpha window, you see it right there on the first choice. Absolute value, 6 minus 4. Whoops, 6 minus 4. And then we're subtracting, and I'll go again, alpha window, choose absolute value, and it's 3 minus 8. Press enter, we get the answer. And if you can key something into your calculator, you should do that, right? Why not? Makes the answer a little bit easier to do. Okay. Question number 5. Not very well. A lot of people chose letter E because they were not sure how to multiply. So let me show you a tried and true method. There's lots of ways to do this. You can FOIL, expand, all these kinds of things. But sometimes you could just, you could draw a box to multiply these. And that makes it a little bit easier. Like here, we've got 4C minus 3D. So 4C minus 3D. And in here we have 3C plus D. And what I'm going to do is I'm going to multiply these. It's kind of like a Punnett square. I'm going to multiply these first two terms. Well, 4 times 3 is 12. And C times C is C to the second power. Okay. And then we're going to multiply these two together. -3 times +3 is -9. And then C times D is CD. All right, we're just kind of multiplying as we go here. Then I'm going to multiply these two. 4C times D. I think that's going to be a 4CD. Let's continue. Let's multiply the last two together. That would be a -3D squared, right? Because when you multiply, you add the powers. And if you weren't sure it was D squared, you'll see that every single answer has a D squared on it, just like every single answer has a C squared on it. So even if you weren't sure about that, it would work out. Now, when I go to write these out, we've got 12C squared and a -3D squared. So I know I need those two answers. So I could safely get rid of this one, and I could safely get rid of this one. Because while they both have a 12C squared, they are both missing this -3D squared. So now we got choice 1 and 3. So just by doing that alone, we could have gotten rid of the people that chose B and the people that chose D. That's like 19% of people would have a better shot at getting the answer. Well, now we want to go ahead and add these terms up. So I'm going to go ahead and write them out. We have 12C squared. We have a -9CD. All right. We also have a positive 4 CD. And we have a negative 3D squared. Well, I think you would agree when we add these up, minus 5 CD. Okay. And that gives us the correct answer. So again, just kind of taking a look at this. So again, there's lots of ways to multiply these things out, but I think this would help you out the most. Okay. This is question number 7. And so let's look at this. 55% of people got number 7 right. This one here, which I think is an easier question, only 36% of people. So maybe word problems people do a little better on. I don't know. Well, the question tells us that we're modeling this growth by this equation here. So I'm going to write that out. 3 times 2x, 2 to the x power. And it says, importantly, x is the number of years after the beginning of the year 2000. So for example, they're saying x will be 0 in the year 2000, x will be 1 in the year 2001, and so on. They want to know how many will it be there in 2006. So this is just checking, first off, can you use your calculator? Secondly, can you plug the numbers in? So what would go in for the x? We're trying to find 2006, and we're told the year 2000 was a 0, right? When x is a 1, we're at 2001. So 2006 would be, let's see, a 1, 2, 2 would be, gosh, what would that be? X, so 0 is 2000, 1 is 2000. Oh, it'd be a 6. Okay. Let's type that into your calculator, right? We go to our calculator and type that in. 3 parenthesis 2 to the power of 6. 192, which is letter B. Okay. Okay, let's kind of continue on this one. Again, we've had this for 12 minutes so far. The question wants to find out, as we're looking at this, we want to find Manus's average speed in kilometers per hour. So we need to think about this. Average speed. How do you find out the average speed of something? I think the average speed is always going to be the change in distance divided by the change in time, right? So our time goes from 8 a.m. to 1 p.m. So we think about that 8 a.m. We have 8, 9, 10, 11 o'clock, 12 o'clock, 1 o'clock. That's a total of 6 hours, right? No, we're starting at 8 o'clock, my fault. So we're starting at 8 o'clock. So we go to 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock. That's a total of 5 hours. And what's the distance? Well, 510 minus 105. Key it into our calculator, and we wind up with letter H, 81 kilometers per hour, right? Because this is kilometers and this is hours. Okay. Again, thinking about this idea. Okay, question number 9. Number 9, we don't even need to know any math at all. We can just use the fact that things are drawn to scale, okay? So you could use like your pencil as a ruler if you want, or the side of your bubble sheet as a ruler. And I know that this distance here, if I put this in here, that distance is exactly 221. They want to know how long this distance is. How far is this? Now, what's kind of, well, a little sad, a few people thought the answer was A, 13. They thought this whole distance here was 13. Well, shoot, just that part alone is 16, right? So I'm thinking that people that were here were just marking whatever on their test. And I'm sorry you're doing that, but you want to take advantage of these opportunities and really want to do the best you can, right? Well, I know this distance is 21. So I've got two more line segments that are exactly the same length as that. And so you would just see like, gosh, how many of these does it take? And lo and behold, it takes two of them. Each one of those is a length of 21. So the answer is 42. Okay. If you wanted to do the traditional math way on this one, what you would do is look at this triangle, and then you would look at the large triangle. And you would pick a side off the small triangle, which is 8. And 8 would correspond to this length on the big triangle. And you pick a side off the small triangle again, which is 16. And that would correspond to this whole length, which we don't know. And then you would go ahead and cross multiply, which would give you this. And then divide both sides by 8, which is 42. But I think that it's the fact that it's drawn to scale makes this one way faster, okay? Use that. It is always drawn to scale, always. Okay, number 10. Number 10 wants us to find out how many minutes it takes her to run 1 mile. Though this one's kind of sneaky, all right? But it seems like people did okay, 58% got it right. What this statement means is they want to find out the rate in minutes per mile. That's what they want to know. How many minutes it takes to run 1 mile. Well, let's write down what we have so far. We have 15 miles. Now we're trying to go into minutes, right? This is 2.5 hours. And I think an hour is 60 minutes, right? And I think a half hour is 30 minutes. So I think that's a total of 150 minutes. Use your calculator and you wind up with exactly 10 minutes per mile. Okay, not too bad. Let's keep going here. Okay, question number 11. I think question 11 is a bit of a stinker. It's the first one that I think is truly, man, this is a rough one. But it also, like, less than half of us got it right. A lot of people thought the answer was A. So they tell us how many marbles that a bag has. And they want to know how many more red marbles do you need to add so the probability of drawing a red marble is 3/5. There's an algebra way of doing this, but I find like the non-algebra way to be much more faster and efficient. Now, 3 divided by 5 is 0.6, right? So we're trying to get the probability to 0.6. Well, right now, let's see what the probability of drawing a red marble is. Well, there's 8 red marbles out of a total of 24. And if I divide those, I wind up with, gosh, what do I wind up with? I didn't work that one out. 8 divided by 24. I wind up with 0.33 repeating, right? So we need to add a lot more marbles. So I'm going to do a thing called guessing and checking. And I'm going to utilize the fact that these numbers are in order. I'm going to guess the middle number, C, 20. And if 20 is too many red marbles, well, then guess what? So is 24 and so is 32, right? So I'm going to guess 20. So our probability of red will be, well, we're adding 20 more red marbles, right? And that means the total's also going to increase by 20 marbles. I use my calculator for that, and I wind up with 0.63. I'm trying to get 0.6. So that's too much. So I can eliminate these 3 choices. Now think about it. Just by doing that alone, 26% of people would not have guessed those 2 answers. Now this is really close to 0.6. So I'm going to back off and try 16 instead, right? I'm going to guess 16 marbles. Oh, again, we had 8 out of 24, right, originally. So let's add 16 red marbles to it. When I use my calculator and divide that, sure enough, I get 0.6 and we have it. So it's got to be letter B. It's got to be letter B. Okay, we got time for just a few more here. I don't want to keep you more than 20, 25 minutes here. Okay, this is number 12. And they're telling us, and this is what they gave. I went ahead and drew a graph here to help us out a bit to kind of see it. They're telling us that this point here is a midpoint. Now remember, a midpoint means that you're exactly in the middle between two things. So the distance apart is the same. And they tell us point C is over here. So this is point C. So I got to figure out what the coordinates are of point D. So let's think about this. Here this is. Well, point D's got to be somewhere like over here, right? Somewhere over here. Now, I think both the X and Y values have to be negative to be over there. So we can safely eliminate these three choices. Now, that's 35% of the people, right? Just by drawing a picture and plotting these points, we can get rid of 35% of the mistakes that were made. Now, there's a lot of ways to go with this. Here's what I like to do. I like to think, okay, I'm going to go down. Let me do this in red. We're going to go down a distance of, let's see, 1, 2, 3, 4. We're going to go down 5 and over 1, 2, 3, over 4. So let's do the same thing. Let's go down 5, 1, 2, 3, 4, down 5 and over 4. And there we are. And we are at the point -2, -4. I mean, negative, hold on a second here. What did I mess up? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. -2, -4. Why am I? Ooh. Oh, no, that's right. Yes. Oh. So when you're doing these things, right, when you're drawing your pictures, this is a good thing to learn from, is it's important to plot the points correctly. So I'm not going to fix this. I kind of want you to see the error. The other point is 6, 8, right? Now 6, 8 is right here. It's not there. So we're trying to go this route. So now let's go back and check it out here. 1, 2, 3, 4, 5, 6, down 7 over 1, 2, 3, 4. We'll do it again, down 7 and over 4. So that's at -2, -6. And if I look at this, there it is. Okay, I think graphing is probably an easier way to do it. Some people don't like to graph. They want to use the midpoint formula, and that's fine. The midpoint formula just says, if you add up the X's and add up the Y's, you'll get the midpoint. Well, the problem is, in our question here, we know the midpoint, right? So we know we're at 2, 1. And I got to have the X's, and all I know is 1 point, right? You can see how this is kind of getting a little deeper into algebra, whereas the graphing's a little quicker. But what you would do is you would just solve this equation. You'd let 2 equal this, because those are the X values. Solve for that. Oh, whoops. All right, I'm just going to halt that for a bit. I really like the graphing. Okay, he'll make mistakes. I'm looking for us. We've got time for one more, and that will be number 15. This will be the last one that we'll do here. And I mention this because only 42% of people got it right. And this is a pure calculator question. Now, we know in math, or hopefully the word of means to multiply, right? So let's do this. 3%, which is 0.03. We're going to multiply that by 4.14 times 10 to the fourth power. And I'm just going to use my calculator to do this, right? So 0.03 times 4.14 times 10 raised to the fourth power. That's it. Just type it into your calculator. Now, I'm going to go ahead and make a video of like all these questions worked out. I should get it done within the next week or so. I'll post it here. So feel free to do that. And that way you can actually look at the exact math questions that you missed. All right. Well, take care. Enjoy yourselves. Bye-bye.